This is Geometry Unit 11, Lesson 9 on volumes of revolutions and cross-sections. So in this lesson, we're going to be thinking kind of in 3 dimensions. We're going to be looking at a 2-dimensional object and imagine what happens if we made it a 3-dimensional object. So the first thing we want to look at is a volume of revolution. It's the 3-dimensional shape that is swept out when a 2-dimensional region is rotated about a line. The line is often, but does not have to be one side of the 2D region. Okay, so for example, I have a rectangle right here, and I have a line that is one side of the rectangle. If I imagine this spinning, all right, so it goes around like this, and if you spun it faster and faster and faster and faster, the shape that you're actually making is a cylinder. So if you rotate a rectangle about some kind of axis, whether it's the side of a rectangle or some line, you will create a cylinder. Now there's several different ones that you could come up with. This is just one. Here's another. Now what if you had a circle that was rotating around a line, going around like this? If it's rotating around a line, notice that there's a hole in the middle. Okay, you imagine this spinning faster and faster and faster. What shape do you actually have? Well, this is actually called a torus. It looks more like a donut shape. Okay, toruses you run into in higher mathematics, but this is a donut shape. That is a torus. So you have to kind of imagine what would happen, what would the figure look like if you spun it around in a circle to make it a 3-dimensional object. So that is volumes of revolution to make 3-dimensional objects. You should be able to kind of visualize what kind of 3-dimensional object is formed by rotating a 2-dimensional object. The other topic we're going to talk about today is cross-sections. A cross-section is the intersection of a 3-dimensional object with a plane. Remember, a plane is a flat surface. So I think of it as, imagine slicing through a 3-dimensional object with a very sharp knife. So if the cross-section is the shape made by the slice. That's what a cross-section is. So if you took a knife, for example, what would be the possible cross-sections of a cube? So here's a cube. If we took our knife and sliced it right down the middle, right down here, like that, what shape have we formed? Well, this is a cube, so this cross-section will be a square. If we did a cross-section sideways, like this, if you cut your knife down through like this, you have created this shape right here. So if I can outline it for you. You've created that cross-section. The square was right here. There's the square. All right, cross this way, you have a rectangle. Now, if you cut off a corner of the cube, you have created a triangle. Pretend that you cut off the corner, you've got a triangle. Triangle, I can't spell either. And then for this one, if you cut a little in on the side and across the bottom here, you have created a trapezoid. There is a trapezoid. So those are the possible cross sections of a cube. Now, question is, those are 4 different shapes that you could make. What is the greatest number of sides of a polygon resulting from a cross section of a cube? Well, let's take a look. What we're looking at on this is the plane that you cut with would have to intersect all 6 faces. So if you're going to cut this, you got to imagine you're cutting it, you would have to angle your knife so that you could cut all 6 faces. So there'd be 6. So you create a hexagon. You can see right here, if you could somehow cut so that you're touching all the faces at the same time, which would be very difficult, you would have a hexagon. And that is the most that you could have. So you can't have any more than the number of faces for a cross section. Okay, now the last cross section we're going to look at is a right circular cone. The possible cross sections of a cone depends on where you cut it. If you cut it straight across the top right here, you've created right here. If you lop off the top, you make a circle. Because it's parallel to the base, it will have the same cross section of the base. If you cut it at an angle on the tip of the cone towards the apex, you have created just an oval shape. It won't be a circle because it's on a slant. It's going to go kind of like this. Looks like that. If you cut it if you could imagine cutting it right through the apex, straight down, slice it in half, the face would be a triangle. And if you went to just one side of the apex and just took your knife and sliced straight down right there, you have created this shape. All right, well, what is that right there? That kind of looks like a horseshoe. Well, it's actually a parabola with the base cut off. If you extend this down, this would be a parabola on both sides. It's a parabola that's cut off at the base. So those are the different cross sections that you can. So this is two-dimensional stuff, thinking in three dimensionals. You have to, and backwards. So you have to be able to visualize what cross sections are and volumes of revolution are.